July 22nd, 1962. Cape Canaveral, Florida. An Atlas Agena rocket lifts off the pad, carrying into the sky the first spacecraft in human history, built to reach another planet. 293 seconds later, a range safety officer presses a single button. The rocket is blown apart in mid-air over the Atlantic. The cause isn't an engine failure. It isn't pilot error, because there was no pilot. It isn't sabotage, a storm, or human error in the usual sense. The cause fits on the tip of a pencil. One engineer, transcribing a formula from a notebook into program code, failed to add a small mark above a single letter. That mark cost the United States many millions of dollars, delayed the race to Venus by 5 weeks, and entered history under a name given to it by science fiction writer Arthur C. Clarke, the most expensive hyphen in history. It took less than a second. The world was different after that. To understand why one small mark could cost so much, we need to go back a few years, to a time when humanity didn't yet know how to calculate rocket trajectories anyway, but by hand. October 1957, the Soviet Union launches Sputnik 1, a simple metal sphere with antennas just beeping in orbit. But for America, it sounds like an alarm bell. A country that considered itself the world's technological leader suddenly discovers that someone else got to space first. What later becomes known as the space race begins. But this isn't just a contest for prestige. It's a race of ideas, of engineering solutions, and, more important for our story, a race against time. In 1958, NASA is created. The agency doesn't just need to catch up with the USSR, it needs to overtake it, and fast. Inside the agency, the Mariner program takes shape, a series of spacecraft meant to do something no one had ever done. Reach other planets, not orbit Earth, not just reach orbit. Cross interplanetary space and send back data from Venus, the planet closest to us, shrouded in thick clouds that hide its surface from Earth-based telescopes. No one had done this before. No one had ready-made calculations, ready-made trajectories, ready-made software. Everything had to be built from scratch, under conditions where every week of delay meant the risk that the Soviet Union would get there first. The computers of that era weren't laptops or servers. They were room-sized machines, programmed by hand, with memory measured in a few kilobytes. Engineers calculated trajectories and guidance equations on paper, in pencil, by hand, then handed those calculations to programmers, who manually transcribed them into machine code. This is exactly where the crack opens through which disaster will slip into history. Between the engineer's hand, writing a formula on paper, and the programmer's hand, typing that formula into code, there is no automatic check. There is only a human eye, fatigue after a long shift, and one small symbol that means far more than it appears to. In the engineering documentation for Mariner 1's guidance software, there was a mathematical variable responsible for smoothing the rocket's velocity data. The formula included a small horizontal mark above a letter, a symbol mathematicians call an overbar, or overline. It indicated that the value should be averaged over time, rather than taken as an instantaneous reading. When an engineer copied the formula by hand into documentation for the programmer, that thin line above the letter, whether from haste or illegible handwriting, was not copied over. Newspapers at the time mistakenly called this symbol a hyphen, though technically it was an overbar. The name stuck, and the story has been known ever since as the missing hyphen. Without that symbol, the program treated velocity readings as instantaneous rather than averaged. As long as everything went smoothly, this didn't matter. The error slept inside the code, showing no sign of itself. July 22nd, 1962, 9:21 a.m. The Atlas Agena rocket carrying Mariner 1 lifts off from Launch Complex 12 at Cape Canaveral. At almost the same moment, a second, independent failure occurs on board. One of the ground-tracking radar systems, meant to relay the rocket's position data, malfunctions. Because of this radar failure, the ground guidance system switches to a backup velocity calculation algorithm, the very one missing the averaging symbol. Every tiny bit of noise and static in the transmitted data was now interpreted by the onboard computer as a real, critical deviation from course. The rocket begins receiving commands for sharp course corrections in response to interference that didn't physically exist. The rocket starts swerving from side to side, drifting off its planned trajectory. On the ground, operators watch the vehicle veer off course, the deviation growing worse by the second. If the rocket continues on this path, it risks coming down either over populated areas or in busy North Atlantic shipping lanes. The range safety officer has seconds to decide. At 9:26 a.m., 293 seconds after liftoff, just 6 seconds before the rocket was scheduled to separate from its second stage, after which destruction would no longer have been possible, he sends the destruct command. Mariner 1 breaks apart over the Atlantic Ocean. Its radio transmitter keeps broadcasting for another 64 seconds as the wreckage falls into the water. The spacecraft was, quite literally, still trying to reach Earth until its very last moment. Chapter 1. The price of one line. The cost of the Mariner. One mission is estimated at roughly $18.5 million in 1962 dollars, more than $150 million in today's money. For comparison, in 1962, that sum could have built 5 or 6 B-52 strategic bombers, or funded a small research university for a year. All of it vanished in under 5 minutes of flight, because of an ink line about 1 millimeter long that never made the jump from notebook to code. Here's what's interesting. Engineers didn't immediately understand the cause. The investigation took days. Specialists worked through dozens of possible explanations. Engine failure, a guidance system error, a fuel problem. Only when someone methodically compared the original handwritten formula against the final program code did the missing symbol come to light. That's when science fiction writer Arthur C. Clarke, hearing the story, coined a phrase that would outlive both him and the rocket itself. The most expensive hyphen in history. Transition. But what happened next matters far more than the mistake itself, because NASA now faced a choice that would define the future of the entire space program. Chapter 2. Fear doesn't get to pause. In the middle of the space race, a failure of this scale could easily have triggered a full program shutdown, a public congressional investigation, months of audits and rechecks. That's often exactly what happens after disasters. But NASA couldn't afford that. The Soviet Union had already made several attempts to reach Venus. If America got stuck in a months-long bureaucratic investigation, the advantage would be lost for good. Fortunately, NASA already had a backup, nearly identical spacecraft, Mariner 2. Engineers frantically rechecked the entire codebase for similar errors, fixed the missing symbol, and re-verified all of the guidance software. Just 5 weeks after the disaster, on August 27, 1962, Mariner 2 launched from the same pad. Transition. And what happened next showed something important. Sometimes, one disaster is the price paid for a success that follows immediately after it. Chapter 3. The spacecraft that fixed everything. On December 14, 1962, Mariner 2 successfully flew past Venus at a distance of roughly 34,000 kilometers. It was the first successful flyby of another planet by an interplanetary spacecraft in human history. The probe gathered data on Venus's atmosphere, its magnetic field, charged particles in the surrounding space, and the planet's surface temperature. This was the first scientific data ever obtained directly from another planet in the solar system, rather than through Earth-based telescopes. Without the Mariner 1 failure, Mariner 2 might never have gone through that accelerated, exceptionally thorough retesting. Perhaps paradoxically, It was the disaster itself that made the success that followed so clean and so complete. Transition. But this story has one more, less obvious consequence. One that lives not in the history of space exploration, but in the history of programming as a profession. Chapter 4. The lesson the entire world of programming learned. The Mariner 1 incident became one of the first widely known illustrations of what would later be called code review culture, the practice of mandatory, independent rechecking of code by multiple specialists before it goes into real-world operation. Before this incident, transcribing formulas from handwritten notes into program code often happened without any systematic, formalized verification. After Mariner 1, the aerospace and defense industries began developing the first protocols for mandatory verification of mission-critical software. The incident became a textbook example in software engineering of how a tiny, almost invisible detail can bring down a system worth tens of millions of dollars. Decades later, this same list would grow to include other similar stories. The mixed-up unit of measurement that doomed the Mars Climate Orbiter probe in 1999, and the single line of code that took down a telephone network, blocking 75 million calls in 1990. Here's the real paradox of this story. We now live in an era where computers check computers. Modern code passes through automated testing systems, static analyzers, dozens of layers of verification before it ever gets near a system controlling anything important. And yet, more than half a century after Mariner 1, the exact same kind of mistakes keep happening. In 1999, the Mars Climate Orbiter probe, worth hundreds of millions of dollars, burned up in the Martian atmosphere because one team of engineers used the metric system and another used imperial units, and no one cross-checked the units between them. In 1996, the Ariane 5 rocket exploded 37 seconds after launch due to a software error in number conversion inherited from a previous rocket model. The losses totaled around $370 million. Technology has become immeasurably more complex. Checks have become stricter, more automated, more layered. But the bottleneck has stayed exactly the same. It's still the moment when one person hands information to another person, or a person hands information to a machine. It's precisely at that seam, where one system of understanding ends and another begins, that the most expensive mistakes in the history of technology keep being born. The more complex our world becomes, the less room there is for one missing mark, and the more it costs when it slips through anyway. Let's go back to where we started. Cape Canaveral, July 22, 1962, 9:26 a.m. The range safety officer presses the button. Over the Atlantic, a brief flash lights up and fades. A few minutes ago, this was humanity's first attempt to reach another planet. The engineer who left out one small mark above one letter probably never knew that his line of code determined those 293 seconds of flight. He wasn't trying to make history. He was just tired, or in a hurry, or simply didn't notice. It took less than a second. The world was different after that. Exactly 5 weeks after this disaster, humanity would finally reach Venus. But that's a different story.